they put the security guy after lunch. I think everyone's had something good to eat, and everyone can just kind of like sit back and have an hour-long sleep now. I'm pretty sure that's why I'm after dinner. But I hope this will be more interesting. I really want this to be a very enjoyable talk. And as you can see from the talk title, I really tried to get that across. That was my goal. So I'm here today to talk about CSP, XXP, STS, PKP, CAA, ETC, OMG, WTF, BBQ. Now, I need to test audience interaction before I get started. Raise your hand if you know at least one acronym from my slide title. Okay, now keep it up if you know 2. Keep it up if you know at least 3. 4? Okay, let's get interesting. 5? Okay. I wonder which ones you all know. So I'm going to talk about the first 4 acronyms here, the first 4 or 5. And the rest of my talk is probably going to be kind of like lightning talks, as introductions to each one of these technologies. But there's actually one more acronym missing off the end of my slide title. And I know you all know it because I know that you're all thinking it, and it's this one. So the same version of my talk title is probably something like Modern Web Security Standards. This is what I want to talk to you about today. I want to introduce you to each of these technologies and tell you what they can do for you. We all know why we should deploy security because it's the right thing to do. But if I'm going to do it, like, what is it going to give me? What can I get back? And that's what this talk is about. So I want to get things kicked straight off. I'm going to talk about the first acronym in my slide title, which was CSP. And that is something called Content Security Policy. I'm a huge advocate of CSP. If you have ever seen me anywhere, on Twitter or in person, I probably will have been talking about CSP at one point or another. It's a fantastic mechanism, and there's so many different things that it can do to actually help you. It's a security mechanism, but I don't want to talk about that stuff. I want to talk about the good stuff. So it was originally designed and built to stop something called content injection. You imagine you've got your homepage here. This is a rough mock-up. And you have a comment section at the bottom, and it's meant for people to leave reviews about how fantastic your website is and how much they love all of your products. Except some smart ass comes along and they type a script tag in, and they submit the comment, and then the comment with the script tag goes into the page, and now you have a script tag in your page that shouldn't be there. We call this cross-site scripting. It's content injection. Now, all of you take a look at the source attribute on this script tag. Raise your hand if you want this script tag on your page. So there's one person down here at the front, right? We can all look at this and make an informed decision that we don't want this, but browsers lack that context. They lack that awareness. We can look and say, whoa, evil.com, probably don't want that. It's called keylogger.js. We really don't want this. But the browser doesn't have that awareness, that context. And with CSP, we can give it that. But an attacker might not inject just a script tag like this that references with a source attribute. They can also inject an inline script as well. And this becomes even more difficult now because you've lost those 2 pieces of information, the domain and the file name. Now it's just inline script. So the browser has even less information because it doesn't know where it came from. Did the host put that there, you, or has the attacker typed in their comment with this script tag inside it? So the browser has no information now, and it's even more difficult to mitigate this. And this originally is what CSP was designed to fix, and it has grown to encompass many more things than that as time has gone by. So content security policy itself is just a HTTP response header. You're probably familiar with all kinds of different headers from different aspects of development work. We've got the server header, the status header, the date, encoding, how's it compressed, cache control things. CSP is just another header that sits in there alongside all the others. So you deliver the content security policy header, and inside the header, you put the policy that you want to enforce on the page. So you have to build that policy and send it. Now, the policy itself is built of one or more directives of your choosing. I've got a subset of them here. These are what we refer to as the Fetch Directive. So these control where the browser is allowed to go and load content from. So let's take something like the image source in the top right. You would specify the image source and say, right, Mr. Browser, you are allowed to load images from these domains. And you give it a list of domains, 2, 3, 4, 10, whatever, wherever you expect to load images from. You would then do the same with the font source and say, right, these are the locations that I load fonts from, so on and so forth. And then things get really powerful when you get to the script source. Because now you say to the browser, right, you're only allowed to load script from these 2 websites and nowhere else. And you can start to take some very serious control of the page. So to show you a really basic policy of how that might look, this is pretty much the simplest CSP that I could ever think to write. We've got the declaration of the header, and we're delivering default source. So this is where all of those other directives will fall back to if they're not specified. Self is a keyword, which just means my own domain, and this other website, cdnjs.com. So you're saying to the browser, by default, you can only load stuff from these 2 locations, from me and from my CDN provider. And if you were to take this and actually just deploy this onto your site, it would completely neutralize the two attacks that we just talked about. Because think about the first one, the script tag. It was loading with a source attribute from evil.com. Well, the browser's going to look at evil.com and say, well, it's not on this whitelist, so I'm not going to load that. The script will not be loaded, will not be executed. And the second one, the inline script. All inline script like that is banned in CSP because the browser has no information on which to make the decision. So you'd have to externalize that file, reference it from your own domain, and then it would match on the self directive. So this is a really powerful policy. And the problem is that none of you could deploy this. I couldn't deploy this because we all load stuff from everywhere. We all have CDNs for like our JavaScript, our style sheets. We have little social widgets and tools and things that we load in. So you need to fine-tune your policy. You need to develop your policy to suit your application. So we'll take the default source. By default, we'll load stuff from ourselves. Hopefully, we should be pretty comfortable with loading things from ourselves. If you're not, you have other problems that I can't help you with. And then you define the next directive, like script source. Now, a new directive like that overrides the default. So if you want to load scripts from yourself, you specify the self directive again. And then I've put these other two domains in there. And what this means now is that I can have script tags like this on my page. The browser will come through, parsing the DOM. It will look at the source attribute and say, right, ajax.googleapis.com, is it whitelisted? Can I load script from that domain? Yes, I can. I'll pull it in. Off we go. If it's not in the whitelist, throw it away. Don't load it. And that is super powerful. But you need to keep going on like this, fine-tuning your policy. So we call them source lists in CSP. So you'd have your script source, the directive, and then the source list. You do the same for styles, for images. And you slowly go through and specify, these are the locations where I expect stuff to come from. And it can only come from these locations. But it's not just about loading content either. As I said, they're the fetch directives where we go out and fetch things, assets back into the page. We can actually start to control what the browser is allowed to do in terms of sending data externally as well. I'm a huge fan of the form action CSP directive because you're allowed to control where forms can post data to. Now, if I have a login form on my website, and let's say someone has changed it, maybe an attacker injected it, some reason, whatever the reason, it's changed, and it's now going to post here instead of back to my own login endpoint. Do we want the browser to do that? And hopefully the answer is no. Don't put your hand up. I know you're going to. Hopefully the answer to that is no. We don't want the browser to post our login form off to some third-party origin. So we specify the form action and say form action self. If you're going to submit a form, only ever send it back to me, nowhere else. And maybe you do have a couple of other locations where you legitimately post forms to. You just add those and say, right, if you're going to send a username and password somewhere, these are the places you're allowed to send it. And hopefully, it's just going to be yourself and maybe one or two other sites. Frame ancestors is a really good one as well. If any of you here tried to put this iframe onto your site and frame me, we see this commonly used in an attack called clickjacking, where an attacker will do something like they'll get a bank's login page and they'll put it inside an iframe and they'll put a transparent form over the top. So when the user thinks they're clicking on their bank's login form and typing, they're not. They're clicking into a transparent overlay. And this will completely neutralize that because the browser will see this iframe, it will try and load my site, read the header, and say, you're not allowed to frame this site. You don't have permission. And again, you can block all sites from framing you, or you can only allow 2, 5, 12, whatever you need to frame your site. And this starts getting really, really more powerful as you go through CSP. And I particularly like these two, because right now we're seeing a drive towards encryption on the web that we've never seen before. More and more sites every week. Every time you go to your favorite news website or forum, more of them are switching from HTTP to HTTPS. And that's a great advancement for web security, but it can be hard to make that transition, to make that change. These two directives will help you do that, because if you have a site, legacy sites that are on HTTP to start with, it's a process for them. They have to migrate to HTTPS, which means you need to go find all your source attributes, your images, and change everything to be the secure version before you can migrate. And if you get that wrong, I'll show you in the demos just after, there's warnings in the browser. If you don't set it up properly, if you don't do it right, you will get warnings. If you did something like this, you have just one simple image tag on your page, and it's got HTTP in the source attribute. And that's it. The browser will take away your green padlock, it will take away the secure icon, and you will get a warning that says this page is not fully secure. And that one tiny image of a cat has completely ruined the thing that you were going for. So the upgrading secure request directive is the way forward now. Block all mixed content would have just blocked this image, but we don't want to do that. We can fix it automatically with upgrading secure requests, which will ask the browser to rewrite this tag on the fly as it's going through the page. So the browser would get down to this image, it would look at the source attribute, and it would rewrite it to HTTPS for you. So this asset may have slipped through to production. It may be a legacy page that someone forgot about. Maybe a developer just had a bad day and missed the S off. It won't happen. The browser will save you. So you can get the browser to almost join forces with you and say, look, I expect everything on this page to be secure. If it's not, make it. Rewrite the page for me. Make these things HTTPS. And that is really, really good because it stops your users from getting errors. It stops things from being insecure, which was the whole point in doing this in the first place. So these all help us in various different ways, but CSP can break things. It's like any mechanism, any policy. You deploy this wrong, and oops, we forgot to whitelist our JavaScript CDN. Your website now has no JavaScript, or maybe no styles. It's not going to look good. It's not going to work good. You can break stuff with CSP, so you need a way to test it safely, and we have one in CSP. And you issue exactly the same policy, exactly the same header, but in report-only mode. So you add these two words onto the end of the header called report-only and deliver the exact same policy. And what that will do is say to the browser, look, I want to deploy this. Don't take any action, but just tell me what you would have done. Like, if I gave you this policy, what would the consequences be? And if you have a look in the console, it will output these errors and say, right, if you gave me this policy, I would have blocked like these three things. But no one wants to do this. No one wants to zoom in and read that error message. There's a better way of doing this. And you can actually get the browser to send you this information using CSP reporting. So we've added a new directive on the bottom line here. And you can specify a HTTP endpoint where the browser will send a report when something violates your CSP. So if you've got that image that's not supposed to be there, or it's on HTTP instead of HTTPS, the browser will fire a post request with a JSON payload that contains all the information about what went wrong. And it'll come to your website and say, hey, I've just loaded your page, and you said everything should be HTTPS, but I found this image that's not. Here's all the information. And it's like the best bug report ever because it has all the information that you need and the steps to reproduce. And we generally don't get that from QA. So this is a really nice feature to have. So I want to show a couple of these. We've got demos as we go through each one of these acronyms, and I want to actually show that these, they do work. These are like super useful things that we can have. So the very first thing that I want to do with CSP, I have a little script tag here. I'm just going to copy onto my clipboard. And I'm actually going to use the conference website to do this. So I'm not going to do anything too bad, don't worry. Everyone turned off the Wi-Fi on their phone as well, right? So I've got this script tag here, and I'll let you take a look at that. So it's just a really simple script tag. I'm just going to create a script tag with an alert that says hi, and I'm going to append it to the head of the document. Now, what I'm simulating here is if that script tag got there. Yes, I'm injecting this on the client, but if it was already in the page or it got there some other way, it would be the same thing. Obviously, I'm not going to actually hack their website whilst I'm on stage. So if we run that, of course, we will get the alert because there's a script tag on the page that is now telling the browser to do that. So do you think this would work if I go to any website and do this? What do we think? Should that just work? Is that a valid expectation? What if we go to my website? I'll do exactly the same thing. I'll go to the console, clear the errors, paste exactly the same script, except this time it doesn't work. And again, it doesn't matter how the script got there. Maybe it was there on the server, maybe en route, whatever. But the browser now knows, because of my content security policy, it says here, refuse to execute inline script because it violates the following content security policy directive. And if an attacker had got that there somehow, someone had put that there maliciously, it would have been blocked. And this is like the core value of CSP. But we can do more cool things with it. Like I said, I've got a couple of demo pages here. Now, I want to show you actually what mixed content does. So this demo site here has lost its green HTTPS marker. You deploy HTTPS, you want that green padlock, you want the secure icon. That's why we do it. That's the reward. But if we take a look at this page, you will see that this image here is a HTTP image. And that's why they've lost that marker. So they've had the UI degraded. They've had their bonus taken away. And I said that we had a way to fix that, and we do, with upgrading secure requests. So on this demo page here, it's exactly the same thing, but you'll notice that I've still got my green HTTPS and I've still got my green secure marker, but exactly the same scenario. if we take a look at this image that I'm loading in, it's a HTTP image tag, but I've not lost my marker. I've not lost my green secure. And the reason is that if we take a look at the network tab and have a look, you'll see I've got content security policy, with upgrading secure request set. So let me just zoom back out, get rid of this. We don't need that. So that's telling the browser, no matter what happens, no matter what this image tag says, you make the thing secure before you do it. And if we actually look at the waterfall view there, you'll see that it made a request straight to HTTPS. So it didn't send the HTTP request, get redirected, and go back. We saved that whole round trip thing as well. It just made a secure request straight away. So the browser will save you from mistakes, from malicious actions, from things that get to production that shouldn't be there. The browser will just help you do that. And this is one of the ways that a lot of news sites recently, I don't know if you've noticed, there's a big trend in America and the UK especially, where news websites are going HTTPS in droves now. And these guys have been online for years, decades, and they've got pages of content that go back 5, 6, 10 years. And do you think they're going to get like an intern to come in and go back and find all the image tags in like 30,000 news articles and switch them? They're not. Go look at a news article from like 10 years ago. It'll be HTTPS with a green padlock, inspect the source on the page. Everything everywhere will be HTTP, but none of it will be, because they're all using this to make sure that things remain secure. And the last thing that I want to show is what you can do with the reporting. This is really powerful. Full transparency, this is one of the sites that I run. And I set this up specifically to do this because no one else seemed to be doing it. So you can ask the browser to send you those reports, and this service collects and ingests those reports for you. So you can literally just have a nice table of information. I monitor for multiple different sites. You'll see them all throughout the reports there. And the browser will post you this JSON payload. We parse it out into nice tables. You can do the same. You can collect your own reports. You don't have to use an external service. Of course, we've got the raw JSON payload as well, and then just a nice view of what's happening. And things get really interesting if you start graphing trends over time, because you can look at this and come and say, right, okay, we have like a fairly stable baseline, but you can see a few days ago I had a massive spike in a particular kind of report, and it was the font source. So there was a font somewhere on my website doing something it shouldn't. I actually found this at the time. It was because I embedded a tweet, and Twitter was trying to apply styles to elements around it, and I block that because I don't let third-party content alter style attributes. So you can see that happen. You can get that feedback and be like, whoa, there's been a big spike. Something's changed on my website. Maybe it's an oversight. Maybe it's just an innocent mistake. Maybe something's actually wrong or broken, because a lot of these errors will actually cause breakages on your site. So yes, it's a security mechanism. Yes, it's all about security, but there are lots of things that it can do for you outside of that. And these are the things that I really want to start harnessing and telling people about, because everyone looks at security, and I heard everyone sigh at the beginning. Don't say you didn't. I heard everyone sigh. They're like, oh, the security guy, ugh. Security can be helpful. I don't want to deploy security for the security benefits. I want to know what it can do for me. And this is kind of where I'm trying to take it. So the next one, because I want to get through all these kind of like lightning introductions. The next one was XXP from my slide title, which is XXS protection. Now, the attack that I talked about at the beginning just there was cross-site scripting, where an attacker somehow gets JavaScript into your page that shouldn't be there. And browsers actually have native defenses built in alongside those you can deploy with CSP. And we call it the XSS auditor. It will look at the page and try to figure out if an attack is taking place, if the user's at risk, and then the auditor may take action based on its determination. Now, not all browsers have them. Like Firefox doesn't actually, but I keep all the browser icons in here. And I was speaking to Martha earlier, and I was going to tell you about how crap different browsers are at this, but she asked me not to. So I'm going to remain professional and not say anything about which browsers are good and which browsers are bad. So XXP is another response header. You may detect a very familiar trend coming along here. You define XSS protection, and again, you deliver the policy to the browser, because what you can do with this is control the auditor, because sometimes the auditors, they make mistakes, they can be tricked, they might be over-aggressive or under-aggressive, and you can control what the auditor does and how it behaves. Now, XXP is a lot more simple, because this is the first policy value. That's it. You just send 0. And what that says to the browser is disable the auditor. Now, this is only for really brave websites. If you are absolutely sure in your own defenses, you can disable the auditor. I wouldn't recommend this one. This one, the next one, 1 is actually the default. This is the default setting in the browser anyway, so the auditor is on and will take action. But I don't like the default, and you will see why in the demo in just a minute. I actually prefer this one, which is telling the browser, if you detect an attack, just stop the user. Don't try and fix it. Don't try and improve the situation. If you think something is going on that is bad, stop. And then more importantly, the next one, tell me about it. If the browser is taking action because it thinks your users are at risk, do you want to know about that? And hopefully the answer to that question is yes. These defenses are built into the browser. They're already doing this. You just don't know. Like many people don't. They're just there, and they've just worked by default forever. And you can start to ask it for feedback about this. So I really like XXP because I'm going to dive straight into the demo. There's literally only 3 configuration values, and I want to show you the differences between those. So hopefully, sweet, it worked. Hopefully we can dive straight into the XXP demo. Now, this particular page as well, actually, if you want to have a look at this, just find me up on Twitter, and I'll send this link out. You can go along with this in real time if you want. This one has XXP set to 1, which is the default anyway, but I've explicitly defined it. Now, if I reload this page, there's a JavaScript alert on the page, OK? So we'll just have a look at why that is. And it's because I'm loading in a particular script file from one of my other websites. So if I open that in a new tab, it's just loading in, again, similar JavaScript file. It's just loading in that alert. So there's nothing fancy going on in the back end. It's literally just a straight HTML page that gets sent back. Refresh the page, you're going to get the alert. Now, if I take a copy of this script tag and go to the address bar, what I'm going to do here, I'm just going to make up a get parameter. I have no idea what that is. It doesn't matter. Make up a get parameter and paste the script as the value that you want to send. And now load the page. Where's my alert? There's nothing going on the server. You can go check this out yourselves and do this on other websites. This is the browser's native defenses kicking in because the browser has seen that in the GET request. And it saw the exact same script tag come back in the response. So the browser's thinking, hang on a minute, if you put this in here, it gets reflected back in the page. We call this reflected cross-site scripting. So the browser thinks this is an attack taking place, so it has disabled this script. And if you look over here, we actually got an error in the console. The XSS auditor refused to execute the script because it thought an attack was taking place, but it's not. I've tricked it. So it's not always good, and I think this is why people should be a bit more explicit in their configurations, like mode block. So this is the exact same page, exact same everything on the back end, except the header is different. It's now in block mode. So refresh the page. I have my JavaScript alert. Whoa, didn't mean to do that. Do exactly the same thing. I'm going to go find the script tag in the page. I'm going to take a copy of that. And I'm going to do the same thing again. Just make up a get parameter, paste, and go. So now the exact same scenario has happened. The browser thinks that an attack has taken place, but I've told it to just stop. If it thinks that something is wrong on this next page, don't load the page. If you genuinely think an attack is taking place, should we continue? Should we allow that to happen? So in this particular scenario, it says to the browser, look, if you think that an attack is taking place, just block the page. And it says here, blocked by the XSS auditor. So again, it's detected that attack, but rather than trying to fix it and maybe getting that wrong, it's like, you know what? Something is bad here, we'll just stop. And in the background, it sent me a report to say that this is happening. So again, XXP is really powerful. It's a very simple mechanism, and it's already built into the browser's working, but most people, they just don't know it's there, because the browser vendors suck at telling people about this. It's like, hey, we built this cool feature in, and literally didn't tell anyone. So it's unsurprising that no one really kind of comes across this stuff. But we need to. I think we need to take control of these mechanisms, especially the reporting, and just say to the browser, look, if you're taking action to protect people, I, as the host, should know about this. And that's why I think the XXP stuff is also a really important one. So I'm going to launch my slides again. Next lightning talk, strict transport security. This is another super simple mechanism that will give you boatloads of security, yes, but this will make things go faster, and this will fix other problems for you as well. So you need strict transport security if you want your website to look like this. If you're on HTTPS and you've already migrated and you're redirecting traffic to HTTPS, then STS is for you. And again, it's what's driving this huge adoption of HTTPS on the web right now. Every 6 months, I scan the top 1 million websites on the planet, and I track how many of them are redirecting users to HTTPS. And that's the trend line over the last roughly 2 years. And we've seen this massive, just explosive growth because of all of the benefits of HTTPS. And this will help you get there. And an STS fixes a fatal flaw with the browsers, and I do call this a flaw. I do actually think that this is still a problem. So if you don't have, we call it HTTP strict transport security, or HSTS. If you don't have HSTS on your site, let's say you're Twitter, and you're the user, you want to go to Twitter right now, you open your browser, what do you type into the address bar? Twitter.com, would we all agree that was fairly average? Now, you don't type the scheme. Twitter.com is not a valid URL. The browser address bar needs a URL. It's missing the HTTP part. So the browser will fill that in for you. You type twitter.com, hit enter, and the browser will be like, that's not complete. We need http:// at the start. What's the fatal flaw with this? It goes straight to HTTP. Every single browser, every single device that you have, even today, right now, if you've got like the latest version of Safari or Edge or Chrome or Firefox, they all still default to HTTP. So they all want to do the insecure thing by default. And the problem with this is that HTTP was the only scheme on the web at one point. So the browsers have got this like legacy thing weighing them down. But of course, everything should be okay because we send this HTTP GET request, that hits Twitter, and if they're a website serving on HTTPS, they'll send us a 301. So that's all good. The browser will get the 301 and be like, right, okay, I did it wrong the first time, we'll go back properly, and we'll do the GET request on HTTPS like you said. Now, this kind of looks all right. I mean, we've got the complete wasted round trip the first time. So if you've got like 300 milliseconds round trip on the network, you've literally got 2 round trips to get the page, which sucks. But there's a bigger problem. The security problem is that you're doing the whole upgrade process over HTTP, which is not secure. So you start out insecure, and then you're like, hey, we need to upgrade this to a secure connection. But you're still talking over HTTP when you do that, which means attackers can meddle with it and attackers can tamper with it. And it leads to something called Ssl Stripping, where when you make that HTTP request, Eve, the attacker as we call her, she just answers the HTTP request because we have no security. She says, hey, Twitter, give me the page on HTTP. And the attacker just responds back and says, sure, here it is. And that's it. That's the whole attack, done and dusted. Now, if they want, they can install themselves as a proxy and talk to Twitter on HTTPS on the other side. But this is one of the most trivial attacks that exist. Ssl stripping will just completely get rid of all of that HTTPS that you spent that time and money deploying. So this is what we neutralize. This is what we fix. We change the browser's default stance from HTTP to HTTPS instead. And we do that, common theme, with a security header. We call them security headers for a reason. You deliver the strict transport security header, and inside the header you put the policy that you want enforcing on your site. Now, STS is another really simple mechanism because we only have these 3 directives to set. These are maximum of 3. The only one that you actually need to be valid is max age. So we have max age, include subdomains, and preload. Max age is the number of seconds the browser should remember this for. So when I enable this setting in the browser and change the default from HTTP to HTTPS, how long do you want the browser to apply that for? The next one, include subdomains, does exactly what it says. If you set this on your Apex or your root domain, you can cascade that policy down through your whole set of domains underneath, all of your subdomains. And preload we'll talk about in just a moment because that's a special one, and I do like that. So minimum valid policy, how do we get STS deployed? This is all that you need. Valid policy, done, deployed. Single line of config or code if you want to do this in your application, and you set the max age. The browser will come to your website, and it will see this response header. Now, on that first connection, we call it the tofu problem, trust on first use. The first time the browser goes to your website, it doesn't know you have the STS header. It can't. It would need to see into the future. So the first time it connects, it will be insecure. It will do the redirect onto HTTPS, and then it will see this header. And then it will say, right, next time, I go straight to HTTPS, instead of starting on HTTP and waiting for the 301. So with HSTS, what happens now is you open your browser again, and you type twitter.com, and you hit enter. But instead of defaulting to HTTP and doing that whole round trip on the network, the browser will say, nope, we're not allowed to do this because this website turned on HSTS. And of course, twitter.com does. So the browser instead will go straight to HTTPS. Now, yes, again, we have all the security advantages of that, but we just killed a whole round trip on the network. And that can shave like 300 milliseconds off your page load. Yes, the browser will cache the 301 for a period of time, but it's not that much. You know, we still see, I still track in my server logs how many 301s I issue. It's a lot. Use HSTS, kill them all off, and just tell the browser to do it right the first time. And that's all that we have to do. So now the whole conversation takes place over HTTPS. There's no insecure comms, there's no insecure traffic, so we can just throw that one away and do the right thing the first time round. So I want to show this in action again. I don't want to just talk about these things. And you can actually see STS working, and you can actually see the performance advantages of HSTS as well. So I need a website that's on HTTPS, but not. I wonder if the BBC. I just pick on websites as I go. I mean, constructively criticize them. Sorry, that was the wrong term. So, why are they not on HTTPS? There we go. This is how not to do HTTPS, everyone. You go to HTTPS and they redirect you to HTTP. That is a fail barbecue. So I'm going to use the conference website again because they're very good people and they have HTTPS. But we're going to go to HTTP. No. We're going to go to HTTP and watch what happens. There. So this is what we wanted. And what you can see here, what you would expect, I typed in HTTP. My browser would have cached a 301 before, so I typed it specifically. But it hit the network on HTTP, went out to the site, got the 301. And we can see in the waterfall that took, I don't know, like 252 milliseconds. But all that first request does is say, you did it wrong the first time. This is how you do it right. We set the location header here. And that's the location that it then reissues the second request to. So that whole first round trip, as well as being insecure, is just a waste. It's just extra latency, extra data on the network. But again, if we take a look at a site that has HSTS, and I'll do the very same thing on my website. So I'm going to force it. I'm going to force the browser to do HTTP. And what happens is the status code is different this time. Now, it's a 307 here. If we click on this, we can take a look inside, actually. Sorry, there's people at the back that might not be able to see that. We can see here, I got a 307 internal redirect. And the reason was HSTS. So even though, and this is the really interesting thing, I told the browser to do something very specific there. Go to this page on HTTP. And the browser said no. So not only will it fix things, it will actually override user input, because that was my input into the address bar. And the browser just overrode my input and forced a secure connection. If someone has a link to your website, and that link says HTTP and the user clicks it, it will force HTTPS. If they have an old bookmark that is HTTP, it will force it to be HTTPS. You can enforce this on your domain across the board. But we do have that one problem that I talked about, which was the tofu problem. How does the browser know to do this if it's never been to your site? Can anyone actually think, like, how could the browser possibly know this if it's never been to your site? Can we fix that problem? Can we tell the browser something before it's connected to us? There are no hands going up. And I think this is one of the craziest ideas ever, but also the best idea for exactly that reason. I mentioned that other directive called the Preload Directive. And what the HSTS preload list is it's a list that you can request to join. You put the preload token in your header, and then you can come to this website and say, right, I put the preload token there. That's my consent to join the list. You type your domain in here. Of course, I'm already on the list. But then it will say, are you sure you want to preload? And you can submit. And then your domain name goes onto this list. And it's literally just a big old list of domains. You can go look at it. And the cool part of this is that every single browser vendor out there, everyone, Chrome, Firefox, Safari, Edge, all of them, they take a copy of this list and they bundle it into the source code of their browsers. So this is literally built into the source code of the browser. And the really cool thing is that none of you here have probably ever been to my website, but I know that on all of your devices, all of your phones, your laptops, your tablets, somewhere in their source code is my domain name. literally written in because I'm on this list. And what that means is if you try and go to my website for the first time, having never been there, and please do that, I'd love the traffic, that'd be great. If you go there for the first time ever, it will do HTTPS straight away, and it won't do HTTP, do the whole redirect thing, waste my bandwidth, my server resources, and waste the network traffic. So this is really cool. I love the fact that you can literally get your domain name built into several billion devices. Just forget all the security stuff. I did it just for that because I love that idea. But HSTS preloading is really powerful. Like it's the one-stop solution to everything for your site and your HTTPS. So, tracking on time. I've managed to, oops, oh yeah, sorry, I forgot. Crazy projector thing. Let's do that. So, that was HSTS, or STS as we refer to it. Next one, this is probably the most complicated, so bear with me through this one, and then the next one's a lot nicer. Public key pinning is it's a fairly complex mechanism because it protects you against a very complex issue. And the issue is something that we refer to as rogue certificates. So if you want HTTPS on your website, you've got to go to what we call a certificate authority, a CA, and you've got to buy one of these certificates from them. And they're just like text files, basically under the hood. But the trick with these two is CAs aren't perfect organizations. Just like me, just like you, they have bad days, they have security problems, things happen. And you can, in some scenarios, this has happened where someone goes to a CA and says, hey, I'm PayPal.com, I'd like a certificate. And they can trick the CA somehow, maybe fool them, maybe they found a flaw in their system. And people end up with certificates for domains that aren't theirs. And that's a really bad situation. We call that a rogue certificate. Now, of the two certificates that you can see, one is mine that I genuinely obtained myself, and the other one is obtained by an attacker. They've tricked the CA, they've hacked them, whatever it was. Which one is the bad one? Which one should the browser trust, and which one should it not trust because it's a rogue cert? And this is the problem. The browser has as much information as you have right now, and you can't tell. And this is what PKP fixes. It allows you to give the browser some information to know in fact that this one, although it's genuine, it's not something that I asked for, and someone has obtained it illegitimately. So again, hate to spoil a good trend, this is another HTTP response header. It's really easy to turn these things on. You set the public key pins header, and you put the policy inside it. And just like HSTS, PKP is very simple. There's only 3 directives that you can ever set in one of these policies. The max agent includes subdomains, are the same as what we just talked about with HSTS, but the new one, the important one here is this pin directive. So what we do with the pins, you need a minimum of 2 of them. And when you set up HTTPS on your websites, you have to have an encryption key on your server. That is like the foundation of everything. So basically what you do is you hash that key and you put the value into the header. That's what the SHA-256 hash is. It's a hash of your key. And the idea with the second one is that somewhere offline and somewhere safe, you generate a second one and you take the hash of that. And what you say to the browser is, look, on my servers, I have these 2 encryption keys. Here is the hash of them. So when you come back to my website, the key that I use, you can hash it and see if it's the same one. And then you can know whether it's one of my 2 that I have. You can have more. You can have like 3 or 4 or 5. But the idea is you give the browser the list and say, look, when you come to me, the key should match one of these things. This is what I will be using. Now, the pin itself is the hash of part of the key. If you're interested in this kind of stuff, the command is up there. I will make the slides available, but for the purpose of a quick lightning talk like this, it's a hash of the key. And you don't just have to hash your own keys either. If you've ever dealt with certificates in your organization, you'll know there's more than just your certificate. There's a certificate chain of at least the leaf, the intermediate, and the root. And they, just like yours, they all contain keys. So you can take the hash of any one of these 3 keys. So if you don't want to do all the key management and looking after your own stuff, you can actually just lock yourself to your CA and say, look, when you come back to my website, I use Let's Encrypt as a CA. When you come back to my website, I should have got a certificate from Let's Encrypt. If it's from like the China Post Office or like crazy Russian government CA, it's probably not me, so don't trust it, even though it's valid. And that's really powerful. GitHub.com is probably the largest site that I know of that does this, and they've locked themselves to 2 CAs called DigiCert and VeriSign. So if, Russian government goes crazy, or some government goes crazy, or some hackers compromise a CA and get certificates for GitHub.com, that would put us all at a really high level of risk. but they're protected against that if that happens. So it is only for fairly high-value sites, not for the flower shop or the pizza shop down the road. And again, it has reporting. If you deploy mechanisms like this, you absolutely must have reporting enabled. Don't use my service again, full transparency. Like, stand up your own. It's just JSON ingestion. But you have to have that feedback. If you're deploying these mechanisms, you need to know what's going on in production on your site. So you define the report URI directive, and again, you get those JSON payloads back. So the browser will say, hey, I came to your website, and I got this certificate that doesn't match what you said should happen. Here is a copy of everything, so that you can go away and debug that and think, have we made an error in our policy? Or is someone actually trying to do this? Is there actually a problem? Now, the interesting thing with PKP is I don't have a demo of this. And I'm intentionally not demoing this because I guess trying to do a demo of PKP in like 2 minutes would be like trying to do a demo of how to handle weapons-grade plutonium in 2 minutes. There's only one way that ends for you when you go away and try it, and that's very badly. So PKP needs a lot more thought going into it. And if you do want to deploy it, there's a lot of documentation out online. I have lots on my blog. There are tools that will help you do this. But be warned, if you deploy PKP and you deploy it wrong, you can break your website for the duration of max age. So if you have a max age of a month and your policy is wrong, your website will not load for a month. So be careful. Some of these mechanisms are very powerful, and they're meant to do good. But if you aim them wrong, they become a nice big foot gun as well. I said foot gun. I saw that. So the last one, lighten things up a bit now. I want to go for a really simple mechanism that was actually only introduced September last year, September the 7th, called Certificate Authority Authorization, or CAA. And CAA, again, is, as you can probably guess from the name, it's to help you in your drive towards getting certificates for your website to go HTTPS, because these are powerful things. If I am the bad guy and I steal one of these certificates from you or somehow get one, I can impersonate you. If you have encrypted traffic, I can decrypt it. There's lots of bad things that can go wrong, so we do need to take care. We do need to have some precautions in place. Now, as I mentioned, I use Let's Encrypt to get my certificates. If you're currently paying for them, Let's Encrypt will issue them for free. There's a couple of constraints, but you can get these things for free now. But as I said, there's not just one CA in the world. There's not just 10. There's at least 200 odd that are out there. So I use Let's Encrypt, as I say. But all of these other organizations can issue a certificate for me. You can approach them, and you can say, hi, I'm scotthelme.co.uk, and I would like a certificate. Now, the CA doesn't know whether you are me or not, and they're meant to go through a verification process to prove that you are. Now, of course, that process is never perfect, and mistakes have been made. But wouldn't it be good if the CA knew that I didn't want to use that particular CA? If the CA could say, yes, I'm Let's Encrypt, and I know that Scott wants to use me, but, if you go to VeriSign, VeriSign can say, well, I'm not the intended CA of this website. Right now, you have no way to restrict that, and this is what CAA gives you. So we're going to break from HTTP headers, now we're going into DNS, because CAA is a DNS record. So we've got our typical records, A records, quad A's, text records, whatever it is. CAA is a brand new type of DNS record. And what you do is you create a CAA record, and you literally just put in the domain of the CA that you authorize to issue certificates for your domain. So you can see here I've got the issue directive set to Let's Encrypt. So now if someone goes to a CA, let's say we go to the China Post Office, who are a CA, you go to the China Post Office and say, hey, I'm scotthelme.co.uk. I would like to go through the verification process and try and get a certificate. The first thing that CA has to do now, according to the guidelines that govern them, they have to say, right, you claim to be scotthelme.co.uk. I'm going to go look if they have a CAA record set. They do. Okay, that means I need to check it. And they will pull the record back and say, nope, this domain can only have certificates issued from Let's Encrypt. Now, they will stop at that point. There's no opportunity for the attacker to carry on and try and fool them or try and trick them or try and convince them or do anything, because they can do that DNS lookup and say, well, you're not the right person. And it's that simple. CAA is literally just a DNS record, and it gives you a huge level of protection. So I want to take a quick look at that. Now, I can grab any domain again that I know that doesn't have them. If you have no CAA records set like this, the mechanism had to be fully backwards compatible, of course. So if you have no record set, that's presumed to be just there are no restrictions. Anyone can issue, which is how it's always been. So this is fully backwards compatible, and you can choose to set your own records. Just like, for example, I know this one website that does all these geeky security things. Just like this one. So I've got all of these CAA records set. And you can control whether the CA can issue standard certificates or wildcard certificates as well. So only the CAs on that list there are authorized to issue for my domain. Now, historically, anyone was. There was no way to control this. It was just basically a free-for-all. You know, if you could go to a CA and prove you owned a domain, off we go. Now, they have to check these records. So again, I always use the China Post Office as an example. If you go to the China Post Office and say, I would like a certificate for this domain, they're going to look at these DNS records and say, well, we're not allowed to anyway. So what's the point in even going through the process? And we've stopped anything from going wrong before it actually even started. So if you want to create these DNS records, they are fairly simple, but there is this really good tool that I use online, sslmate.com. And you literally just come to the tool and say, right, which one should we do it for? We'll do it for my domain. And then there's just a big list of all the CAs that you could possibly use. And of course, where is my favorite one? So a whitelist, let's encrypt. Are there any Polish CAs? Does anyone know? Can someone shout out the name of one? Is there a Polish CA? No? I normally try and find, we'll do Swiss sign as well. So let's say we wanted these two CAs. And this is the really good thing as well. Again, we're seeing a reporting mechanism. If someone goes to a CA and tries to get a certificate for your domain, and that CA says no, because I'm not authorized, you can ask the CA to tell you about it. You can ask the CA to say, hey, look, someone tried to come to us and get a certificate for your domain, and you said that we're not allowed to do it, so here's all the information. Because that could be someone actually trying to do something malicious again. So there's so many opportunities to get different bits of feedback, and CAA is exactly one of them. And then that's it there. Those are the 3 directives you need to set in DNS. So 3 DNS records. You've got issue for Let's Encrypt, issue for Swiss sign, and then what we call the IODEF record, which is the email address where you want the report sending. 3 DNS records to deploy the whole thing, and that's it. And you get all the protection that CAA offers. So I think that's pretty good. Hopefully, like, all of these mechanisms are close to free for sites to deploy. Now, let me switch back. All of these things hopefully are close to free to deploy. There's obviously overheads and maintenance, but in terms of the actual cost of deployment themselves. So I just want to give a quick overview because we've done like a rapid fire succession of the different lightning talks there now. And I want to just jump back to the beginning, CSP, very quick recap. So you can whitelist all of the different sources of where your application can load content from. You don't actually even need to do that if you want. If you just want to use one directive in CSP, like upgrading secure, a lot of people will go to a website like mine or Twitter's or wherever, someone who's been doing CSP for a while and they've developed a mature policy. And they'll look at the policy and be like, holy crap, that is like big ass wall of text, like everything in there. And that puts people off, but that's where you get to a year from now. When you start with your CSP, you just start with like the very first directive. And you're like, right, we're literally going to turn on the first thing and see how that goes. Okay, that went well. We'll expand it. We'll add this. This feature looks cool. We'll turn that on as well. You build your policy over time. So if you do go out to look at other sites and their content security policies, don't be put off by their complexity because that's not where you'll start. Start with just one thing. Start in report-only mode and enable reporting and just go from there and build it over time. But there are actually more things than I showed you about CSP because I literally did not have enough time to cover them all. So go check CSP out. There's a lot of documentation and information available. The Mozilla blog is particularly good for that. Next one was XXP. That was XSS protection. We were talking about the browser's native defenses with the XSS auditor. This is already on by default in browsers that have them. So you're actually already using this whether you know it or not. And that's kind of the thing that just makes me a little bit uncomfortable. I think, if you've got something like that happening and being used, I think people just need to be aware of it, configure it explicitly, and choose what you want the browser to do. I don't think that things that are on by default that no one knows about are always necessarily the best things to have. So just deploy that header and just make a conscious choice and say, actually, we want to turn it off. Or maybe we want to ratchet it up to full strength. But again, be aware that it's there, that it's already working. Whether or not you deploy this, you already have the XSS auditor in most of your users' browsers anyway. Next one was STS. If your website is on HTTPS and you're redirecting traffic there, you absolutely need this. This is not optional, in my opinion now. Like, if you're making the conscious choice to redirect traffic to HTTPS, you should solidify that and say, yes, okay, we have this whole redirect process, but actually, we're just going to commit from now on HTTPS. But that's the key point there. Once you deploy this, you are making that commitment. If you have 1 month in your max age, then you're saying to the browser, remember that for the next 1 month. And it will top the cache up every time it visits again. The goal is to get a max age in the 1 to 2 years range, so the browser will have the protection for a long period of time. So start small. The very first time you deploy STS on your website, you should not have more than 10 seconds in the max age. That's where Facebook.com started with theirs. So you don't need big values. To test this out, start small. The thing I love about this, if you deploy STS with a 10-second max age and it breaks your website, you can just turn it off, and then when someone rings you, you'll be like, oh, I don't know, works for me. And it's all gone. All the evidence is gone. So STS with a really short max age is great. The next one was PKP. The interesting thing with PKP is that I might have to stop talking about it soon because PKP is very powerful, like I said, and I didn't demo it because you can't demo it quickly. We have a term in the wider industry, unfortunately, called HPKP suicide, which is where you deploy PKP wrong with the wrong values, and then the browser will refuse to load your website. And a couple of quite large websites have done this and committed HPKP suicide, as we call it. It's the huge fuck gun that is HPKP. And because of that, Chromium have actually announced that they're going to deprecate support for it this year. If they don't back out of that decision, it may actually be gone this year. And the reason for that is, yes, it's very dangerous. Yes, it has like a nasty habit of backfiring if you get it wrong, but a lot of its functionality was replaced by CAA, the next mechanism that we talked about, where you can start to take a little bit of control over which certificate authorities can issue for you. So CAA doesn't get us all the way there, actually. There's still a little bit of the journey to go. And quick bonus round, I do have time. Quick bonus round, there's another thing coming soon called certificate transparency, or CT as we refer to it. Now, CT compliance is actually coming next month. It's coming in April. And all of your websites, if you're on HTTPS, have to be CT compliant next month. And I struggle to find people that even know what CT is when I walk around and talk to website operators. I'm like, hey, CT compliance next month. How are you doing? What? Like, CT is coming next month. Certificate transparency. Google it. Have a look at it. It's a really simple mechanism. And it requires all CAs to publicly list every certificate they issue. So you can go to what we call the CT logs, certificate transparency logs, and you can watch them. And every time a CA anywhere in the world issues a certificate, they have to write an entry onto the end of the log to say, I've just issued a certificate for PayPal.com. I've just issued one for ScottHelme.com. And what you can do, the idea is that you monitor these logs and you can see who's getting certificates for your domains that you control. And if it's your thing, it's a Merkle hash tree, which is the blockchain. I don't like using that word. We are literally using the blockchain for the CT logs so that there's an auditable, immutable log of all certificates ever issued. But your CA, your site has to be compliant next month, so please do check that up. Please do have a look at that. And of course, all of these are about security. I'm hugely passionate about security, and I do it because I enjoy it. But I'm trying to sell security now, not on the security benefits. We all know that we should do it because it's the right thing, because it makes us more secure, it protects us and our users. But there has to be, in my opinion, there has to be a bigger reward. I want it to make my site go faster. I don't want to see errors. I want to know if things break on my domain. And hopefully all of the different technologies that I've just introduced you to can do all of those things. Now, I hope that people will take that away. Maybe you've seen one or two that you think they're good for us, they might apply. Maybe you've seen others that you're less interested in. My goal is to hopefully let you know they exist, they're out there. You can test and deploy them with minimal to no cost, really. And I hope you can take all of those away and secure all of the things. Thank you very much.